Hello and welcome to 7.7 Notes. So in Lesson 7.5 and in Lesson 7.6, you learned how to use the side lengths of a right triangle to find either the sine or the cosine or the tangent for the acute angles of the triangle. And then once we knew that trigonometric ratio, once we knew either the sine, the cosine, or the tangent, then we used those trigonometric ratios to find missing lengths. But now today we're going to learn how to find missing angles. And we're going to learn how to find those missing angles by using inverse trigonometric ratios, inverse functions. So again, as I told you in a previous set of notes, we're going to learn 3 more buttons on your calculator today. And those three buttons are the inverse tangent, inverse sine, and inverse cosine buttons. Okay? So reading now, inverse tangent states that if the tangent of some angle A equals some number x, then the inverse tangent of x, and by the way, this is pronounced inverse tangent. We never say tan to the negative 1. So if you see a tan and then a superscript negative 1, you never say tan to the negative 1, you say inverse tangent. Okay? So the inverse tangent of x will be the measure of that angle in degrees, like 45 degrees or 32 degrees or whatever. Okay? Continuing to read, if the sine of angle A is equal to y, then the inverse sine of y is equal to the measure of angle A. And finally, inverse cosine states that if the cosine of A is equal to z, then the inverse cosine of z is equal to the measure of angle A. And by the way, that looks a little bit different because it didn't come out when I typed it, so I had to kind of change it like that. Okay, so moving right along. If you have a triangle, a right triangle, of course, remember this only refers to right triangles, then the inverse tangent of BC divided by AC is equal to the measure of angle A. Okay? Let me move along here. And also, the inverse sine of BC divided by AB is equal to the measure of angle A, and the inverse cosine of AC divided by AB is equal to the measure of angle A. So I'm going to give you kind of a quick summary of this whole lesson. Okay, of course I'll explain it in more detail in a moment in other frames of this lecture, but here's a super quick summary. So referring to the tangent, so let's say if we know that the tangent of angle A is equal to 0.75. Okay, then the inverse tangent of 0.75 is going to be equal to the measure of angle A, which, if you look on your calculator, is 36.9 degrees. And that would be your answer. So you just press, oops, I forgot to put the 1 there. It's called the inverse tangent. And like we went over in class, I had you take out your handy-dandy calculators in class, and I showed you how to use the inverse buttons. If you miss class, it's basically, on most calculators, as far as I know, it's using the sine, cosine, and tangent button, but it's also pressing a second button, like the second level button, that changes the level of that button. So it's usually found on the sine, cosine, and tangent button, but it's inverse tangent. So if you press like a second, or that other button, and then this button, and then 0.75, you get 36.9. Your calculator will tell you 36.9. And you have to use your calculators to get these inverse ratios to find these angles. Okay? That's the only way we really know how to do it in classes, by using the calculators. So that's how you would use inverse tan. Okay? Again, by using your calculators. Give me a moment here. And moving right along here, let's talk about the inverse sine. So let's just say, for sake of argument, that the sine of angle A is equal to 0.75. Okay, just throwing out that number there. Then the inverse sine of 0.75 will equal your angular measurement, and the inverse sine would be 48.6 degrees. So like I said, I showed you in class how to do this, but if you want, for sake of argument, we can try to try going through an exercise here on YouTube. It's kind of hard because I'm not there with you, but basically what you do is you have to press some other button. It's either like your blue button or orange button, or it might say second on there. It sort of depends on your brand of calculator. So you press that other button to turn your sine button into the inverse sine button, and then you press the left parenthesis, 0.75, right parenthesis, and then your equals button, and you should all get 48.6 degrees. If you don't get 48.6 degrees, one of the first things you should investigate is if your calculator is in radians or degrees. So you would go into your settings, go into your mode, and change the mode from radians to degrees, because this only works if your calculator is in degrees. And by the way, I want to mention that obviously sine is BC over AB, because if your eyeball was here, then it looks like opposite over hypotenuse, right? Sine is opposite over hypotenuse. And then, of course, the tangent is BC over AC, because tangent is opposite over adjacent. So if your eyeball is there, then it's opposite over adjacent, which is BC over AC. And so, moving right along, the last one. Like I said, this is a quick little review, or I'm sorry, summary, a quick summary. I'll explain it more in detail in a second. But inverse cosine. So again, cosine is equal to adjacent over hypotenuse. Okay, so if your eyeball is right there at angle A, this seems like it's the adjacent side to you, AC, and then AB is the hypotenuse, so it's AC over AB. And again, just for sake of argument, let's just say that the cosine of angle A was 0.75. Then the inverse cosine of 0.75 is going to give me my angular measurement, which is going to be, in this case, it would be 41.4 degrees. So again, you can do that on your calculator. Press your second function button, press this button, get it to be inverse cosine, left parenthesis, 0.75, right parenthesis, equals, and then you should get 41.4 degrees. Okay? So this problem should help us understand inverse trigonometric ratios and how we can use them to find missing angles. Okay, so use a calculator to approximate the measure of angle C. Okay, so we want to find out what angle C is. Alright, so here's how we go about doing it. We're trying to find angle C, so step one would be to put your eyeball there. Okay, so there's my eyeball. And from the perspective of my eyeball, from glancing over there, what information do we have? Well, it seems like I know that. And from the perspective of my eyeball, that would be the opposite side, right? And then I know this, which is the adjacent side. So it seems to me that we know something about the opposite side and the adjacent side. So we have information about the opposite side and the adjacent side. And then the next step would be, what ratio is that? Okay, what are we talking about? Sine, cosine, or tangent? So I'd go back to my SOHCAHTOA, and I'd go, well, like we said, it was opposite over adjacent, right? Opposite over adjacent. And so that's this function, opposite over adjacent. So it has to be my t, or tangent. So it's going to be the tangent of angle C is going to be equal to opposite over adjacent, 25 over 20. Okay? And so, moving right along, I just copied that down. The tangent of angle C is equal to 25 over 20. And so the inverse tangent of 25 over 20 is going to be equal to the measure of my angle C in degrees. And so the tangent, or rather inverse tangent of 25 over 20, 25 over 20 is 1.25. So you would, again, press like your second button, turn your tangent button into an inverse tangent button, left parenthesis 1.25, right parenthesis, and then equals. And you should get the measure of that angle in degrees. And so the measure of angle C is 51.3 degrees. Okay? And then also you'll have problems like this. Okay, we're going to have you'll be quizzed and tested on this, and there'll be questions on your homework set tonight. It's going to say solve the right triangle. Okay, so if we're asked to solve the right triangle, or solve solve the right triangle, that means to find the measures of all of the sides and all of the angles of that triangle. So I want the measure of all three sides and the measure of all three angles. So to do that for this right triangle, for this angle, then going back to this triangle, what we have is the measure of angle A then is equal to 180 degrees, right? 180 degrees is the total angular measurement inside of a triangle, minus what we know already, which is the 90 and the 51.3, and we'll get the measure of my missing angle, 38.7 degrees. Okay, and to find the missing length of the hypotenuse, I would just use the Pythagorean theorem. So the Pythagorean theorem states that the hypotenuse squared, or AC squared, is going to equal this side squared, that leg squared, plus that leg squared. And that's where you get 20 squared plus 25 squared. So AC squared is equal to 1025. Take the square root of both sides, and AC is equal to 32. Okay? And then moving right along, oh, actually, no, you know what? I know all my angles now, right? I figured out angle C is 51.3 degrees, and angle A is 38.7 degrees, and I have all the sides, 20, 25, and 32. And I found that 32 by using the Pythagorean theorem. So I'm showing you the way I would solve this right triangle. Once I know two angles, I would just go 180 minus the sum of those two angles and get my third angle. If I knew two side lengths, the easiest way for me is to just use the Pythagorean theorem. But just to kind of drive home, this concept of the trigonometric ratios, I'm going to solve for 32, this length of the hypotenuse, 32, by using another technique, okay, by using a trigonometric ratio. So again, I recopied the triangle here for your convenience, and I'm referring here to SOHCAHTOA, okay, and I have that the sine of angle C is equal to AB over AC. So in this case, I have the sine of angle C, which I know is 51.3 degrees, right? And so from the perspective of C, if I put my eyeball there, then sine is opposite, which is the 25, over the hypotenuse, which is AC, which is the value that I don't know. So I'm going to use my sine of angle C to find out what my value of AC is, or the hypotenuse. Okay? So the sine of 51.3 degrees is equal to opposite, which is 25, over hypotenuse, which is my unknown value, or AC in this case. Okay? And so AC then is equal to 25 divided by the sine of 51.3 degrees. And the sine of 51.3 degrees, by using your calculator, is 0.7804. And then doing that division, you get that AC is equal to 32. So I got the same answer by using the trigonometric ratio of the sine. I got that AC is 32. And on the previous frame, I found that the value of AC is also 32 by using the Pythagorean theorem. Okay, so just a way to confirm it, and also to kind of give us some more practice on using trigonometric ratios, right? So I have now solved this right triangle because I know all three lengths now. I know that the hypotenuse is 32, this leg is 20, and this leg is 25. And I know all three angles. I know that that's 90, that's 51.3 degrees, and that's 38.7 degrees. So I have now solved the right triangle. And like I said, you'll be responsible for doing that in your homework, and on quizzes and tests, you'll also be asked to solve the right triangle. Okay, and again, it just means to find all three lengths and all three angles of the right triangle. Okay, so that's the end of the lecture. If you have any questions or concerns, as usual, please feel free to contact me at your convenience. It would be my pleasure to help you. Okay, bye-bye.